case 9's complement, and the procedure is smaller to the power n minus 1 minus capital N. It means 10 to the power n minus 1 minus capital N. Okay, suppose capital N is equal to 7392. It is in the decimal system, base 10. So how to find out the 9's complement? 10 to the power 4 minus 1 minus 7392. Because small n is the number of digits present in the decimal number. So how many digits involved? 4 digits. 2, 9, 3, 7. 4 digits involved. So 10 to the power 4, then minus 1, then minus this number 7392. Okay, so 10 to the power 4 means 10,000. 10 to the power 4 minus 9 means 49. And then 10 to the power 4 minus 1 minus 7392, it means 9999 and 7392 minus. So 7062. So this is the 9's complement of 7302 is 2607. So this is the 9's complement. Now, so I will tell you some general form of it. 10 to the power n. It means 1 followed by n number of zeros. Okay, let's take an example. 10 to the power 4, it means 10,000. Okay, so you see, first you have 1, this one followed by n number of zeros. How many zeros are there? 1, 2, 3, 4. So these are the n number of zeros. Because if you see here, n is equal to actually 4, and in the 10,000 you have 4 zeros. Right? So n number of zeros are there. And these are means 1 is followed by n number of zeros. Now 10 to the power 4 minus 1. So 10,000 minus 1. This is 9999. So how many 9's you have? 4. 1, 2, 3, 4. So we can say that 10 to the power n minus 1, this is actually n number of 9's. And it can be understood in this way. 10 to the power 4 minus 1, it is 10,000 minus 1, and you have 9999. So this is what? 4 9's. And if you check the small n, if you compare this 10 to the power n minus 1 and 10 to the power 4 minus 1, automatically it can be understood the value of small n is actually 4. So 10 to the power 4 minus 1 means you have n number of 9's. Or yes, n number of 9's. And finally, what you are doing? You are doing this thing, 10 to the power n minus 1 minus capital N. For this particular case, it is 10 to the power 4 minus 1 minus 7392. Then you have this value is actually 9999 minus 7392. And then you are getting 7062. So
Sir,
from
I
this
have a
whole
doubt.
discussion, yes,
Sir, where did this 7392 came from?
I have assumed, I have assumed one number. Yeah,
Okay, sir.
I have assumed one number, right? Here, I think here I have assumed this. This is not came
Okay, sir.
from me, but I have assumed one number. Okay. Now, okay. Now, so the conclusion, what is the conclusion? When anyone asks you to do the nines complement, how to do the nines complement? How to do nines complement? Suppose we have a number capital N. Capital N consists of small n digits. So what you have to do? We have to subtract each digit present in capital N from 9. Okay. So it isn't it? You see, you have a number 7392 in the decimal system. Okay. So capital N is equal to 7392. How many digits are there? Small n is equal to 4. So when you are trying to find out the nines complement, what you are doing? You are actually subtracting each digit from 9, because you are doing this way: 9999732. So what you are doing? You are subtracting 2 from 9, so you are getting 7. You are subtracting 9 from 9, so you are getting 0. You are subtracting 3 from 9, so you are getting 6. You are subtracting 7 from 9, so you are getting 2. So 2604. Sorry, 07. So what you have to check? You have to check how many digits are there in the number. So in this particular case, you have 4 digits. So what you have to do? You have to subtract each digit from 9. So from n number of 9s, you will subtract your decimal number. Okay. You see, n number of 9s. Why I am telling n number of 9s? Because you are using 4 9 here. In 7392, you have 4 digits. So that is why you are using 4 9. And you are subtracting each and every digit from 9. So this is 9's complement. Are you getting my point, what I'm trying to say? Is that any doubt? Is that okay?
No, sir.
Okay.
Yes, sir.
So you see, there are 2 examples. This is one, this is another. So I'll again show you what are the example. So 546700, right? 546700. What is the 9's complement of this? So you can easily find it out. So your capital N is equal to 546700. Small n is equal to 1, 2, 3, 4, 5, 6. So you have to subtract each and every digit from 9. So you have to take n number of 9s, 999, 999, and 007645 minus. So 992354. So this is the 9's complement. Okay, of 546700. You see? Same thing you can do over here. You have 012398. 012398. Right now, this is the number. How many digits are there? 6. So what will be the nines complement? That is, you have to take n number of nines. So 6 nines. And you have 012398. You do the subtraction. 1, 0, 6, 7, 8, 9. Okay. So these are the examples of the nines complement. Okay, and okay. Okay, we will discuss the tens complement a little bit later, or we can write it down. Okay, okay, fine. So I'll show you what is the tens complement. Now, the r's complement, when r is equal to 10, so we are discussing about the tens complement. How to obtain it? The tens complement is equal to 10 to the power small n minus capital N. This thing. Okay. This is the tens complement. So I will compare both. So nines complement and tens complement. If you just compare the basic formula, so in the nines complement, the formula is 10 to the power n minus 1 minus n, or you can simply write 10 to the power small n minus capital N minus 1. And for tens complement, you have 10 to the power small n minus capital N. So if you just compare these two equations, what is the observation? That actually nines complement is 1, complement is actually 1 greater than nines complement, isn't it? Because in the nines complement, what is that formula? 10 to the power small n minus capital N minus 1. And what is the tens complement? 10 to the power small n minus capital N. So in nines complement, if we add 1, then we can easily find out tens complement, isn't it? Because 10 to the power small n minus capital N minus 1, this is actually nines complement. And if you add 1, what you will get? 10 to the power small n minus capital N. So this is actually tens complement, right? So if someone asks you, find out tens complement of 7392. You already know what is the nines complement. So you have to subtract each and every digit from 9. So here small n is equal to 4. So you will consider 4 nines and you subtract 7062. So this is the nines complement. Now you add 1, 2608. This gives you tens complement, because already we have seen what is the difference between nines and tens complement. In the value, there is a difference of 1. Okay, if you add 1 to the 9's complement, you can easily get the 10's complement, right? So, okay, so 10's complement, okay, I'll take another example, 246700, right? Tens complement of 246700. So first you do the 9's complement. The first step is the 9's complement. So how many digits are there? 6. So you will consider 6, 9. And then 246700. Subtract each and every digit present in this number 246700 from 9. So 992357. Now what you will do? You will add just 1. You have 003357. This is the tens complement. Okay, 753300. See, 753300. Same thing happened with the this in this case. Yes, for in this case, you have the 9's complement 987601. You just add 1, so you have 206789. So this will be the 10's complement. Okay, so right now we have an idea how to find out the 9's complement and 10's complement. To observe how many digits present in the number. So you have to take that amount of 9. If small n is equal to 4, so you have to take 4 9s, 9999, and you have to subtract all the digits present in your number from 9. And then you will get your 9's complement of the given number. And if you add a single one to the 9's complement, you will easily get the 10's complement. Okay? Okay. Now we will discuss about the 2's complement and 1's complement in a binary system. Okay. So in the binary system, again the formula is same. Only R will be changed. Okay. Now, in the binary system, the R's complement is actually 2's complement, and R minus 1's complement is actually 1's complement, because small r is equal to 2 in this case. Okay, so how to find out one's complement? Okay, the formula is same. R to the power small n minus capital N minus 1. Okay, or you can easily write R to the power small n minus 1 minus capital. So here R will be 2, 2 to the power n minus 1 minus n. Now again in this case, the 2 to the power n is actually a 1 will be followed by n number of zeros. How? Okay, 2 to the power 7. Okay, yes. So 1 followed by 1, 2, 3, 4, 5, 6, 7. Okay, Now, sir, what is this? How could I tell this thing? Because 10 to the power, in case of 10 to the power 4, we can understand that is 1 will be followed by 4 zeros. Or when we have 10 to the power 5, then we can say that the 1 will be followed by 5 zeros. But in case of 2 to the power 7, sir, how could I tell that there is a 1 and it will be followed by 7 zeros? So the situation is okay, when you have a binary number A0, A1, A2, A3, base 2, so what you have, how could you represent it? You can represent in this manner, right? In this manner, the coefficient will be multiplied by power of 2. So in this case also, when we have 2 to the power 7, when we have 2 to the power 7, you see A1, A2, A3, A4, A5, A6, and A7. And you can easily write it down that except A7, all the coefficients are 0. So your A7 will be multiplied by 2 to the power 7, and then A6 will be multiplied by 2 to the power 6, A5 will be multiplied by 2 to the power 5, plus dot dot, plus A0 will be multiplied by 2 to the power 0. But you see here, except A7, all the coefficients are 0. So automatically what you will find? You will find A7 into 2 to the power 7, and you can easily write A7 means 1. So 1 into 2 to the power 7, it means it is 2 to the power 7. So in this way, we can represent the 2 to the power 7. So 1 will be followed by n number of zeros. Okay? Is that clear?
Yes, sir.
I hope it is clear. No question. Okay. So right now, I will come to this point that r to the power n minus 1. So 2 to the power 7 minus 1. So what we have? We have 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then minus 1. So when you will do this subtraction, what will happen? You have 6 ones, 1, 1, 1, 1, 1, 1. Because you have to take borrow, because you are subtracting 1 from 0. So in every case, you see, you have to take borrow from the next higher position. So your differences will be 1, 1, 1, 1, 1, 1. Okay. So when you will do this subtraction, we will have n number of complement, and for one's complement, if we compare these two, so I'm just comparing like this, that r to the power n minus 1, so 10 to the power n minus 1, here r to the power n minus 1 means 2 to the power n minus 1. Suppose n is equal to 4 over here, also n is equal to 4 over here. So you have 10 to the power 4 minus 1. So 1 followed by n number of zeros. So 1, 2, 3, 4. Here also 1 will be followed by n number of zeros. So 1, 1, 2, 3, 4. Now, if you go for minus 1, so what you have? You have 9, then 9, then 9, and then 9. So you actually have 4 9s. Again, if you do this minus, you are following the subtraction rule. The operation is same in both the 9s and 1s complement. The difference in the subtraction. So in the decimal system, when we are subtracting 1 from 0, I am getting 9 because it is come from the principle, the subtraction principle. And in case of 1's complement, because I have considered it is the base 2 system, so I will follow the subtraction principle of the binary system. So when I am going to subtract 1 from 0, I will have difference 1 and borrow 1. The only difference in the subtraction operation. Okay, so I will have 4 ones. 1, 1, 1, 1. So 4 ones. Okay, so now what we are doing, complement the formula is 10 to the power small n minus 1 minus capital N, where capital N is the decimal number. So what we are doing, each digits present in capital N will be subtracted from 9. Right. Now in 1's complement, we have 2 to the power n minus 1 minus capital N. Now it is the binary number. So each digit present in capital N will be subtracted from 1, because after doing this subtraction, you have only ones, right? Here, 2 to the power n minus 1, when n is equal to 4, so there is a 1 followed by n number of zeros. So when you are subtracting 1 from this quantity, you have n number of ones only. So if you try to find out the 1's complement, what you do, you will subtract each and every digits present in the binary number from 1 only. Okay, so if you subtract 0 from 1 and if you subtract 1 from 1, it will give 1 and it will give 0, isn't it? When you will subtract 1 from 1, it will give 0. When you will subtract 0 from 1, it will give 1. So in 1's complement, there is a very interesting thing. In 1's complement, the 1 will be changed to 0 and 0 will be changed to 1. Because in the binary system, what you have, suppose the number is 11010. This is your capital N. Now we are trying to find out the 1's complement. So you see how many digits are there? 1, 2, 3, 4, 5. So small n is equal to 5. So you have a 1 followed by 5 zeros. So formula is what? 2 to the power n minus 1 minus capital N. So you do the minus 1 first. So you have to follow the subtraction operation in the binary system. You have 1, 1, 1, 1, 1. 5 ones you have. 1, 2, 3, 4, 5. 5 ones you have. Now what you will do? This is actually what? This is actually 2 to the power n minus 1. Now you have to subtract this capital N. So you will write 1, 1, 0, 1, 0. Now you see very carefully, you are actually subtracting either 0 from 1 or either 1 from 1. So when you are subtracting 0 from 1, it will give you 1. When you are subtracting 1 from 1, it will give you 0. The same thing, 1, 0, 0. So simply you are actually exchanging, not exchanging. You are you are changing 0 to 1 and 1 to 0, because if you just see this number, yes. So if you just see this number, and this is actually what? This is 2 to the power n minus 1 minus capital N, means this is actually your one's complement. So you just check these two quantity. So here you see in the original number you had 0, but in one's complement it is changed to 1. Here you had 1, you have 0. Again you have 0 over here, it is 1. Here you have 1 and 1, you see it is 0, 0. So finally your capital N was 11010, and one's complement is actually 10100. You see, from this principle, from this formula. So that is why I am saying in the ones complement system, a very easy way to do that, the easy way to do one's complement, that is convert 0 to 1, convert 0 to 1 and 1 to 0. Then automatically you will get the ones complement. Okay. Now the twos complement. Now in the twos complement, what is the formula? 2 to the power small n minus capital N. For ones complement, what was the formula? 2 to the power small n minus 1. So what is the difference? The difference is actually of binary 1, isn't it? Because in the twos complement, the quantity, the formula is 2 to the power small n minus capital N. For ones complement, the formula is 2 to the power small n minus capital N minus 1. So if you compare these two formula, the difference is the difference of only a binary 1. So when you have to find out the twos complement of 11010, so the first step, just find out the ones complement of this particular binary number. So ones complement, that is 10100, and then add 1 over here. So you have 01100. So this is actually the twos complement, right? So this is all about the nines, tens, nines, twos, and ones complement. I hope you are the concept is quite clear right now. Is that okay?
Yes, sir.
Okay. So right now we will discuss about the subtraction principle. Okay. You see, the direct method of subtraction taught in elementary schools uses the borrow concept. In this method, we borrow a 1 from a higher significant position when the minuend digit is smaller than the subtrahend digit. This seems to be easiest when people perform the subtraction with paper and pencil. When subtraction is implemented with digital hardware, this method is found to be less efficient than the method that uses complements. Okay, so on the pen paper we know how to do the subtraction, but if we implement the same formula when we want to do the subtraction by help of the digital computers, then the efficiency of that method is very inferior. So that is why we are using the complement system to perform the subtraction in the digital computers. Okay. The subtraction of two n-digit unsigned numbers m minus n in the base R system can be done as follows. Add the minuend m to the R's complement of the subtrahend. This performs m plus R to the power n minus n. If m greater is equal to n, the sum will produce an end carry. R to the power n will be discarded. What is left is the result m minus n. If m minus n, the sum does not produce an end carry and is equal to R to the power n minus m, which is the R's complement of n minus n. To obtain the answer in a familiar form, take the R's complement of the sum and place the negative in front. Okay, so these are the procedure. I will explain one by one, then it will be understood. Now here, using tens complement subtract this. So this is one example, how to do the subtraction using tens complement. So you see, is the minuend and it is the subtrahend. Okay, so what is the formula? The formula is m plus capital N. Okay, it means minuend and small n is the subtrahend. So what we are doing, we are subtracting n from m. We are subtracting n from m. So by principle, how could I perform the subtraction operation using tens complement? So the first step, do the tens complement of small n, sorry, capital N, which is your subtrahend. Then add the tens complement of capital N to the minuend, which is capital M over here. So that is why formula is R to the power small n minus capital N. So it is actually R's complement, or for the decimal system, it is the tens complement of subtrahend. Now this tens complement will be added to the minuend. Okay, so this is the formula. So if I take one example, so your m is equal to, suppose the example is 72532, 7, and n is equal to 3250. Minus. So you have to perform the subtraction operation using tens complement. Okay. So how to do that? You see, your capital M is actually greater than N, right? So, and also how many digits are there in capital M? In capital M, there are 5 digits. And in capital N, there are 4 digits. But to maintain simplicity, what we will do, I will make the N of 5 digits. So how to do that? The N is equal to 0, 3, 2, 5. Now it is 5 digits. Previously it was 4 digits, but for the convenience, I am making the N of 5 digits. Okay. So that is why I have put 1 0 in the extreme left. Because if we put the 0 in the extreme left, then the value will not change. Okay. So right now what we have to do, we have to go for the complement, tens complement of capital N. So 10 to the power small n minus capital N. So you know how to do the tens complement of this. So first we will go the nines, do the nines complement and then add 1. So the number is 3250 and I have put extra 0 in the extreme left hand side. So how many digits are there right now? 1, 2, 3, 4, 5. So small n is equal to 5. So you will consider 5, 9 and subtract each and every digits from 9. So 0, 5, 2, 3, 0, subtract 9, 4, 7, 6, 9. So this is the nines complement. Then add 1. So you have 0, 5, 7, 6, 9. So this is the tens complement. Now you will add this number, this tens complement to the minuend. So your minuend was 72532, 72532, and right now the tens complement of capital N is actually 96750. 96750. So you have 2, 8, then 2, then 9, then 16. So right now you see this results gives you contains the 6 digits, but your minuend and subtrahend contains the 5 digits. So actually you are getting one carry. This is the end carry. This is the carry. Okay, so you see it is written here. Okay, I'll again take this. Okay, you see it is first step done. First step I have already explained. Now the second step, if m greater is equal to n, the sum will produce an end carry. You see, in the from the example, you see here it was m. I have already written the m greater than n. For this particular example, the minuend greater than subtrahend. So from the principle of the subtraction in the complement system, when the minuend greater than subtrahend, you will get a end carry. And then you have to discard r to the power n, and what is left? That is m minus n. end carry. Okay, so what was the n? What was the small n? What was the value of small n? The value of small n is actually 5 because your aim was 72530. Sorry, 32, and small n was 03250. In both m and n, the number of digits involved are actually 5. So we have to subtract r to the power n from r to the power n minus n plus n. You have already obtained this result, and this result is nothing but 169282, because capital M greater than capital N. That is why we are getting one carry. So I have to discard this carry. So how to discard it? We will subtract r to the power n from this quantity. That is, I have written, we have to subtract r to the power n from this quantity to remove the end carry. Now small n is equal to 5, and because it is the decimal system, so small r is equal to 10. So you have to subtract 10 to the power 5. So 10 to the power 5 means 1 followed by 5 zeros, 1, 2, 3, 4, 5. So you see r to the power n minus n plus m, this value was 169282, and r to the power n, this value is 1 followed by 5 zeros, 1, 2, 3, 4, 5. So subtract this. So you have 28296. So this is 69,282. So this is the result of m minus n. 69,282. So in this way, the digital computer performs the subtraction. So if you done the subtraction in just only on pen paper, your m was 72532, 72532, and n was 3250, right? 3250. So the conventional subtraction, which we have studied from school. So if you do that, you have 2, then 8, then this is actually 2, then 9, then 6. You see, if you do the subtraction on pen and paper, you are getting the same result, 69,282. And in the digital computer case, when you are doing the subtraction with the tens complement, so you have to follow certain rules and regulation, and finally you are getting the same result, 69,282. So no difference, but the digital computers are more familiar with the complement system, or if we do the subtraction operation with the complement system, then it will be the performance of the digital computer will be more efficient. Okay, so today I'll stop here. So we will discuss we'll start the number system, signed numbers in the next class, I hope so. Okay, thanks for coming.
Thank you, sir.